Hi everyone, in this video we're going to be working on the problems in the final exam study guide. So let's get started here. The ages of 10 children are the following. Let's find the mode. So the mode is simply going to be the number that occurs most often in a data set. So in the data set given here, it's going to be 7 because we see we have 3 children that are age 7. So our mode is going to be 7. Find the median. So for the median, something that's super important to remember, your data set must be in order from least to greatest. So let's go ahead and do that now. We can put it in order. There's 1, 5, there's 3 7s, and then looks like 8, 9, 10. And then a 12 and a 15. Okay, and to find the median, you simply mark off 1 from each end in order until you find the middle number. That is what median is. And so you see we have 2 numbers left in the middle here, so we're just going to take the average of the 2. So if we add 7 plus 8 and divide by 2, that gives us 15 over 2, which gives us the median of 7.5. All right. Now the mid-range is going to be the max plus the min divided by 2. So that's why it's also helpful if we put our data set in order from least to greatest. So we can add the least plus the greatest, which is going to be 1 plus 15 divided by 2, which gives us 16 over 2, which is 8. That's going to be our mid-range. And then our mean is simply we add all of the values together and divide by the number of values. So we've got 10 children here, and I'm going to use our Desmos scientific calculator to kind of help us out. And like I said, we're going to add all the values together. Plus 8 plus 9 plus 10 plus 12 plus 15 gives us 81, and then we can do 81 divided by 10 because there are 10 values in the data set, and our mean is going to be 8.1. Now, on your test, if you see it asking for average, mean and average are the exact same thing. So you'll do the same process were they to ask for average. And then the range, part E, is going to be the greatest value minus the least. So we've got 15 minus 1 is going to give us 14. Again, that's going to be the greatest value minus the least. And then for the last little part here, they want us to calculate the standard deviation. Now, we could go about calculating the standard deviation by hand. That would take this entire video. But during your exam, you're going to have access to Desmos Scientific Calculator, and normally it'll be under main. But if you go to function and then you hit standard deviation, you can type in all of these values and it will calculate the standard deviation for you. So let's do that. They each need to be separated by a comma. So it's going to be 7, 9, 1, 12, 15, 7, 8, 10, 7, and 5. Okay, and we see that our standard deviation comes out to 3.81. All right, let's simplify here. So to refresh your memory, we need to be sure that we are going to calculate, we're going to simplify rather here and use our order of operations, which is going to be PEMDAS. So I'm going to write that up here to help us remember. Parentheses, exponents, multiplication, division, addition, subtraction. So let's start here by rewriting our problem. And let's go ahead and start with this parentheses on the end right here. And we're going to do what's in it first. So 6 minus 3 is going to give me 3. I'm going to rewrite this whole thing. And then after I do that, I'm going to start with these parentheses on the left. And I'm going to do this as well at the same time, since we're both multiplying here. And that's what would come next after I finish that first parentheses. So I'm going to do negative 3 times 8 gives me negative 24. I'm going to rewrite this just as it appears. And then negative 5 times 3 is going to give me negative 15. Okay? All right, I'm going to simply make this plus a negative so that it helps me out. And now all I'm doing is adding. So I've got negative 24 plus negative 2 gives me negative 26. Negative 26 plus negative 15 is going to give me negative 41. All right, what is the least common multiple of 198 and 186? So for this problem, we're going to need to make some factor trees here. And we need a factor tree for each number. So let's give ourselves a little room. Let's start with 198. I know that it is divisible by 2 because the 8 is even. 2 times 99. I know that 99 is divisible by 3 and 33. And then 3 and 11. And 11 is prime, so we can stop. And then for 186, I know that it's divisible by 2 and 93. And then 93 is divisible by 3 and 31. Okay, so let's look at what is common here. We've got 2 and 2, 3 and 3. Okay. So because those are common, I only need to write them once. So the least common multiple, to find it, I can multiply 2 times 3, which is both of those. And then what's left? So times another 3 times 11 here times 31. Okay, so let's use Desmos to help us. 2 times 3 times 3 times 11 times 31 gives me 6,138. And that is going to be my least common multiple. Next problem, they're going to ask us to calculate the greatest common factor of the same numbers. So to do so, if you'll recall what we just did, we had the factor trees, and I'll rewrite them here. We had 198 and 186. If you already have these written down, that's totally fine. No need to rewrite them again. I'm just doing this for the sake of explanation. And then 186, we had 2 and 93, 3 and 31. Okay. So we found that the common factors here were 2 and 3, but we want the greatest common factor. So when we multiply them together, we get 6. The greatest common factor of both of these is going to be 6. All right, problem 5. Convert 32 degrees Celsius to degrees Fahrenheit. Now, you should have access to the formula chart. There are several different formulas you can use for this on your formula chart. I'm just going to pick one. It doesn't really matter. You can use whichever one you like. But I'm going to use the F equals 1.8 C plus 32. Right, so we've got 32 degrees Celsius. Instead of the C here, we're going to put 32 plus 32. All right. And when we multiply 1.8 times 32, that's going to give us 57.6 plus 32. And when we add the both of those together, we get 89.6 degrees. Fahrenheit. Okay. All right, for the next one, we're doing the same thing. We're just going to Celsius this time. So I'm going to use the same formula. You don't have to, like I said, but this is what I'm going to do. F equals 1.8 times C plus 32. We have 56 degrees Fahrenheit. And to solve, we're going to try to get C by itself. So we're going to subtract 32 from both sides. This will cancel, and this leaves us with 1.8. C equals 24. And we can divide by 1.8 on both sides. This will cancel and leaves us with C equals 13.33 degrees Celsius. Using the diagram below, find the difference in lifespan between someone who regularly works on puzzles and someone who frequently feels stressed. So if we look here at the diagram, someone who frequently feels stressed is going to be at -5. And in this problem, they're asking us for, In this problem, they're asking us for the difference. Difference means subtraction. So I've got -5. And then someone who regularly works on puzzles is going to be found at 5, so we want the difference. So 5 minus -5. Now, if we have two negative signs, two negatives is going to make a positive. So 5 plus 5 now is going to be 10. So the difference here is 10. And when we look at the number line, we see that that's true because there are 10 spaces in between -5 and +5 over here. All right, so problem number 8 says solve the equation for x, and we're going to round to the hundredths as needed. Okay, so for this one, like we did a couple problems back, we're still going to be working with order of operations here. So I'm going to write out PEMDAS for us here just to refer back to. And I'm going to rewrite this problem a little larger so we can have a little more room to work with. Oops. It's going to be a -7 plus 2. So first we're going to start with parentheses. And when we have something like this, a coefficient out in front of the parentheses, we are going to distribute the -8 to both terms. And when we do so, we're going to just rewrite this front part here. And then -8 times 2x is going to give us -16x. -8 times -7 is going to give us +56. And then this 2 on the end is going to remain the same. Okay, now we can combine both of these. 56 plus 2 is going to give us 58. X plus 58. And now we're going to isolate the variable. And so to do so, I'm going to subtract 7 from both sides. I'm going to move that over here. And at the same time, I'm going to move this x to the other side. So I'm going to do the opposite of -16. I'm going to add 16x to both sides. All right. When I do all of that, the 7's here will cancel, and the 16x's here will cancel. And over here, I'll be left with 58 minus 7, which gives me 51. And then I've got 16x plus -3x is going to give me 13x. All right, so this looks a lot neater. All right, I'm going to continue up here. 13x equals 51. I can divide both sides by 13 to get that x by itself. This will cancel, and I'm left with x equals, when I divide 51 by 13, I get 3.9 and then 0.92 because it's asking us to round to the hundredths. So I can leave it like that. X equals. Problem 9. Find the complement and supplement of a 27-degree angle. Okay, so complement is going to be an angle that will complement the current angle that we have to make it equal 90 degrees. So I can write an equation for this by saying the complement plus 27 is going to give me 90. Now I can just solve. I can subtract 27 from both sides, and I get x equals 63 degrees. That is going to be my complement. Now a supplement is going to be an angle that can be added to the angle that we have that will make it equal 180. So in this case, I can write an equation still, but this time it's going to look like x plus 27 gives me 180. Okay, so same thing here. I can subtract 27 from both sides. This will cancel, and I'm left with x equals 153 degrees. That is my supplement. All right, problem 10. Convert 27 pounds 5 ounces to kilograms. Round to the nearest tenth of a kilogram and use these conversion factors. Okay, so my starting weight here is in both pounds and ounces, and what I'm going to do is I'm going to convert both of these to just one number in ounces. So let's do that first. I've got 27 pounds, and we know that there's 16 ounces in a pound, so I'm going to multiply these together. And when I multiply 27 times 16, 27 times 16, that gives me 432. And then I've also got these 5 ounces up here. So 432 ounces plus 5 is going to give me 437 ounces. So that's what I'm going to start with. Okay, so now the problem is asking us to go to kilograms. So I'm in ounces. I know that there's 16 ounces in a pound. I can get my ounces to cancel there, but we're still going to kilograms. So I can multiply it times the factor of 1 pound on the bottom and 0.45 kilograms on the top. And the pounds will cancel and my units will be kilograms, and that's perfect because that's exactly what they're asking for. Now, all that's left to do is multiply all of the top together and all of the bottom together. So I get 437 times 0.45 on the top gives me 196.65. Okay. Then on the bottom, I just have 16. So on the top, I've got 196.65 divided by 16, which gives me, it says round to the nearest tenth, so it gives me 12.3 kilograms. Okay. Number 11, convert 4,375 to kilograms. Okay. So here is our acronym here to kind of help us out. King Henry doesn't usually drink chocolate milk or whatever version of that you prefer. We're starting off in grams, which is going to be the standard unit of measure, and we're going to kilograms, which is over here. So that means that our decimal, which is behind the 5, is going to get moved to the left 1, 2, 3 places. So let's do that. 1, 2, 3. It's going to go right here. And so my answer is going to be 4.375 kilograms. All right, number 12. Convert 4.35 liters to milliliters. So same thing here. You can use whatever version of this you prefer. It's just always helpful. So we're starting with liters, which is going to be the standard unit, and we're going to go to milliliters, which is 1, 2, 3 units to the right. So let's do that. We've got 4.35, 1, 2, 3. Decimal is going to go here, and my answer is 4,350 milliliters. Number 13. The circle graph shows the most important problems for 28,350,122 high school students. Estimate how many students for whom drugs is the most important problem. So let's go ahead and set up a proportion here. They are going to ask us to estimate, but let's go ahead and set up what we know. So we know that for 23% of students, drugs is the biggest problem. So we know that percentages are always going to go over 100. So I'm going to take 23% here. 3 over 100. And we know this right here is the total number of students, so that's going to go on the bottom. 50, 1, 2, 2. And we're going to solve for what's on the top. So I'm going to use Desmos over here to help us out just so you can see what I'm calculating. But I'm going to cross multiply. I'm going to take this number on the bottom times the 23. So I've got times 23, which gives me that number right there. And that number is going to be equal to 100x. So 652052806 equals 100x. And then I need to divide by 100 on both sides. This will cancel. And here I can just use Desmos to type in 652052806 divided by 100. Gives me that number right there. Now, if you'll notice, that number is not one of these answer choices. That is why they asked us to estimate. So we're simply going to choose the one that is closest to the number that we got. And when we look at them, we see that that's going to be B. 5,600,000. Okay, video. The ages of 370 ASN graduates is shown by the image below. If this is accurate, how many in a group of 100 graduates are between 23 and 26 years old? All right, so we know in this graph there are 370 graduates. And to solve, we're going to set up a proportion. So we know that that's the total. And we're going to go ahead and put that on the bottom. Out of 370 graduates, we want to know how many are between 23 and 26. So we look at this bar graph right here. This bar, it's between 60 and 80, a little closer to 80. So I'm going to say about 78. So it's pretty close. And then we want to know if the total is 100 graduates. So total goes on the bottom. We want to know how many are between 23 and 26. So since we don't know that, we're just going to call that X. All right, and now we're going to solve the proportion. So I've got 100 times 78 is going to give me 7,800 is equal to 370 times X, which is 370X. To solve for X, I can divide by 370 on both sides. And when I do that, this will cancel, and it gives me X equals, I get 21.08. Okay, and we know that there's not going to be a 0.08 of a person. So we're just going to say X, we're going to round that off to the nearest whole number. So X equals 21 graduates. Okay.
This one says, using the frequency table below for the ages of people in a swimming pool, how many are between 9 and 12 years old? And then also, how many are at least 17 years old? So let's go over here to the table, and we can see that from ages 9 to 12, there is a frequency of 15. So 9 to 12, there's going to be 15 kids, right? And then how many are at least 17 years old? So this means that they are 17 or older. So we need to look at all the categories that includes, which are going to be these three right here. So what we're going to do is add the frequencies of those categories. So 10 plus 9 plus 4 is going to give me 23. That is the frequency. Or people. Problem 16. 10 people bought shoes. The cheapest pair was $39.95 and the most expensive was $89.95. Half of the people bought shoes for $59.95. Which is the best estimate for the total spent on shoes? Alright, well here let's start with what we know. We know that half of the people bought shoes for $59.95. So during this problem, since it's asking for best estimate, we're going to be using our rounding rules. So half of the people that are in the question is going to be 5 people. So a total of 5 people paid about $60 for their shoes. So since we want to find the total, we're going to multiply those 5 people by the amount they spent on shoes. And for these 5 people, we get $300. Now, we need to figure out about how much the other people spent. And the question gives us the most expensive pair and the least expensive. So let's take the average of the two. So about $40 was the least, and about $90 was the most. And we're going to take the average and divide by 2. So we get 130 on the top, divided by 2. And this gives us 65. So we can estimate that each of the remaining people spent $65 each on shoes. Now, just as we did here, we're going to multiply those 5 remaining people by the $65. And when we do that, we get $325. So, now we're still looking for the total. So when we add the 300 and the 325, we get $625 total dollars spent on shoes. Now, let's take a look at our answer choices and see which one is closest. And we see that A is closest. Again, since they're asking for best estimate in this question, it's not imperative that we have the exact answer. 620 is closest. Problem 17. A medication is dosed at 10 milligrams per kilogram of body weight. Using the conversion factor 0.45 kilograms equals 1 pound, how many milligrams should a patient who weighs 125 pounds get? Round to the nearest tenth of a milligram. Awesome. So let's start with what we know. We have a patient who weighs 125 pounds, and I'm going to start by converting that to kilograms because that is the unit of measure for body weight of the medication. So let's start with 125 pounds, and we're going to use our conversion factor here. So pounds is going to go in the bottom, and kilograms in the top. Okay, so we get our units on the top and the bottom to cancel. Then we also know that the medication For every kilogram of body weight, there's 10 milligrams of medication. So when we put this conversion factor there, we get the kilograms to cancel. And this is perfect because they want our answer to be in milligrams. So we need to multiply all the top together and all the bottom together. So when we do 125 times 0.45 times 10, we get 562.5 milligrams. And 1 times 1 on the bottom would just give us 1. Okay, problem number 18. A medication is dosed at 10 milligrams per kilogram of body weight. It comes with a liquid with 2 milligrams of medication per milliliter. Using the conversion factor of 0.45 equals 1 pound, how many milliliters should a patient who weighs 55 kilos get? Okay. So let's again start with what we know. We have a patient who weighs 55 kilograms. Okay, and we don't need to convert to pounds here from kilograms because the medication is dosed per kilogram of body weight. So this is a good example of when we should really take a close look at our question because sometimes they give us extra information that we don't necessarily need. So for every kilogram of body weight, I'm looking at this dosage of medication here. For every kilogram of body weight, there's 10 milligrams of medication. So we get the top and the bottom units to cancel. And then it has a liquid with 2 milligrams for every milliliter. And this is awesome because they want our answer in milliliters, so that's great. These units will cancel, and now we just need to multiply all the top together and all the bottom together. So 55 times 10 times 1 gives us 550. 1 times 2 gives us 2. And when we divide here, we get 275, and our units are milliliters. Problem 19. Use the diagram shown to find angles 1 through 5. So I'm going to make a list over here for ourselves to kind of make a list of all our answers that they want. And so let's take a look at angle 1. Now, if we want to determine angle 1, we know that this line right here is straight. That means that if this forms a straight angle, that means that this angle right here, this 125, and angle 1 both need to add up to be 180 degrees. Why? Because this line is completely straight. So what we can do is we can take 180 minus 125 and we'll get angle 1. And when we do that, we get 55 degrees. Alright, so this one is 55 degrees. Okay, for angles 2 and 4, exact same thing. This line right here we know is completely straight. So if it forms the same straight line as these two angles over here, we know that they must be the same. So this angle, angle 4, is going to be the same as this 125 over here. And angle 2 is going to be the same as angle 1. So that's going to be 55 as well. Okay? And now we can look at angle 5 and we know that it is going to be the same as angle 4. Why? How do we know that? Well, we know that the exact same two lines are crossing and forming the exact same angle as angle 4 because they're the exact same lines. So angle 5 is also going to be 125 degrees. And then lastly, angle 3, we must ask ourselves, well, what do we know about all the angles in a triangle? Well, we know that they all need to add up to be 180 total degrees. So since we have two angles already in the triangle, we can just add and subtract. So 180 of the total degrees in the angle minus 55 minus 55 equals 70 degrees, which is going to be angle 3. Awesome. All right. Problem number 20. Create a stem and leaf plot for the data. Okay, so for stem and leaf plots, all it is a way to categorize data based on, in this case, which group each member of the data is going to be put in. So first, we're going to create groups based on, we're going to have a teens group. So anything that has the first digit as a 1 is going to be in a group. Anything that has the first digit as a 2 is going to be in a group. And then so on. So we're going to take 3, and there's ones with some 4s, and there's a 5 in there too. Now, the way that we're going to account for each member of the data is by adding the second digit behind the first digit in a row. So I'm going to draw a line here. These are our categories, and let's start with the first one. And they're going to be placed in order from least to greatest. So it looks like the least I have here is 10. So I'll put the 0. I'm just going to put the second digit of the number. So 10. Next would be 12. Again, just the second digit. 13. 15. Okay. That's all I have for this category. And this is kind of a shorthand way to categorize the data and organize it, just to save you a little bit of writing. All right, next category, same thing here. Looks like we have two 25s. So I'm going to write 2 5s to account for both numbers. 25, so cross them both off. Okay, and then I have a 27. Okay, that looks great. Next category, 31. And then 35, 37, 38. All right, next category, 42 and 44. And then 51 and 52. Video. Amazing. How much will it cost to carpet a 12-foot by 20-foot room if the carpet costs $18.32 per square yard, round to the nearest penny? Okay, something to be careful of in this problem is we need to make sure that we are multiplying by the area in yards, and the dimensions of the room that they give us are in feet. So we need to convert these numbers to yards before we can calculate the area. So let's start with 12 feet. And we know that there are 3 feet in a yard. So 12 divided by 3, these units will cancel. We get 4 yards. Same thing for the other value. We get 20 feet. We know that there are 3 feet in 1 yard. Feet will cancel. 20 divided by 3 gives me 6.67 yards. Now we can find the area of the carpet that they will need. So to find area, we just do base times height. So we multiply these two numbers together. 4 yards times 6.67 yards gives me 26.67 yards squared. Okay, now we need to multiply the number of yards we'll need by the cost per yard. So we can take 26.67 yards squared times $18.32 per square yard. And that will give us a total of $488.53 that it will cost to carpet the room. Problem 22 says a circle has a radius of 15 feet. Use 3.14 as an approximation for pi and round to the nearest tenth. So first, let's find the circumference. And we know that circumference equals 2 pi r, or diameter times pi. But this is the same, and they give us radius here, so this will be helpful to us. So let's multiply. C equals 2 times, and we're going to use 3.14 here, times 15. And when we multiply that out, we get the circumference is 2 times 3.14 times 15. We get 94.2. And it's asking us to round to the nearest tenth, so we're just going to leave it like that. And our units is feet. Awesome. And again, circumference is going to be the distance around the circle. Now, for area, it's going to be the space inside the circle. And for the formula for that is A equals pi r squared. So let's multiply here. A equals 3.14 times 15 squared. 15 squared is going to give us 225 times 3.14. And when we multiply that out, we're going to get A equals 706.5 feet squared. And since it's area, our units are going to be feet squared. Find the missing side x in the similar triangle shown. Alright, so we've got a missing side here, and we know that they're similar. So because we know that they're similar, we can set up a proportion of the sides. It's meaning that this side is proportionate to this side is proportionate to this side. So what is a proportion? Well, it's just two fractions that are set equal to each other. So these two sides right here are proportionate to each other, so I'm going to put them both on the top. So 9 and x, which we don't know. And then we're going to choose, I'm just going to choose these two sides, and they're also proportionate. So I'm going to put them both on the bottom, 24 and 8. And I'm going to set them equal to each other. Now we can solve for x to solve for the missing side. So to do that, we can cross multiply. 8 times 9 gives me 72. 24 times x gives me 24x. I can divide by 24 on both sides. X, when I divide 72 by 24, it gives me 3. This cancels. So the missing side is 3 inches. Problem 24. A right triangle has legs of 6 and 7. What is the hypotenuse round to the tenths? So I always like to draw a triangle. You don't have to, but it always helps me to look at what I'm actually doing. So we know that the legs are 6 and 7, and by definition, the hypotenuse is going to be the longest side. So that's what we're going to be looking for. And we know that it's a right triangle, so we can draw my little right angle there. And what do we know about a right triangle? We know that the sides are always going to line up with the Pythagorean theorem, so we're going to use that. So what is the Pythagorean theorem? A squared plus b squared equals c squared. A and b being the legs of the right triangle and c being the hypotenuse. So we can fill in what we know and solve for c. We've got 6 squared, 7 squared, and then we can solve for c squared. 6 squared is going to be 36, and 7 squared is going to be 49, equals c squared. 36 plus 49 is going to give me 85. To get c by itself, I can take the square root of both sides, and c, this will cancel the squared. C is going to be the square root of 85, which is going to be 9.2. 9.2. And this is already rounded to the tenths, so we are good to go. This is the length of the hypotenuse. Problem 25. A right triangle has one leg of 8 and a hypotenuse of 12. What is the other leg? Round to the tenths. Okay, same thing, except this time we're going to be looking for a leg, and we already know the hypotenuse. So let's draw my handy dandy little picture. Got my right angle, one leg is 8, hypotenuse, longest side is going to be 12, and we're going to be looking for B. Okay, starting with my formula, I'm going to fill in what I know. 8 squared is going to be A. We're looking for B, and then we know that C is 12. 8 squared is going to give me 64 plus B squared. 12 squared is going to give me 144. I'm going to subtract 64 from both sides. Got B squared equals 80. I'm going to move over here to give ourselves a little room. B squared equals 80. I can take the square root of both sides. This will get rid of the squared and leave me with B equals 8.9. And this is already rounded to the tenths, so we don't need to round it any further. Problem 26. True or false? If two triangles have two corresponding sides with equal ratios, they are similar. Okay, this one is actually going to be false. Why? Well, if all we know is that the sides they have equal ratios, that doesn't tell us anything about the angles that form the triangle. So this one has to be false. We have to know the angles that are between the sides that have equal ratios. So false. You can add this to your notes as well. You must know an angle between the sides with equal ratios. Problem 27, true or false? If two right triangles have equal corresponding leg ratios, they are similar. Yes, this one is true. Why? Considering what we just said. We just said that if they have equal leg ratios, we must know an angle. Well, here, if we know that they're both right triangles, we do know an angle. We know that at least one of the angles in this triangle is 90 degrees. So true. They have to be similar. Problem of this video, true or false, angles are formed where two rays meet at a common endpoint. Okay, so what is a ray? Well, we've got an endpoint, and the other end keeps going. Well, if we have two of those, and they have the same endpoint, and the other end just keeps going, this is in fact an angle. It will make an angle right here. So true, yes. All right, let's get started with 29. True or false? It's impossible to form an angle by using two lines. This one is going to be false. Why? Well, we see it all the time. We see two lines, meaning straight entities that have no beginning or end, and when they cross, they form what are called angles. Right here, we see it all the time. So this one's going to be false. Problem 30. In the diagram shown, if x is 105 degrees, what are the remaining angles? So let's make a list here for ourselves. And trust me, we're going to be able to determine what all these are just by them giving us this one angle, which is kind of cool if you ask me. But this line right here and this line, they are parallel to this line right here. So x is 105. So because they're parallel, that means that they're going to be forming the same angles in the same places. So, and that's how we're going to be able to determine what all of the other 7 angles are. So angle x is 105. Because we know that, we also know that angle 3 is 105 because their angles are formed by the same lines. So 105 and 105, 3 is going to be 105 degrees. Now, because this line right here is straight, we know that angle x plus angle 1 has to equal 180 because it's straight. And so if we take 180 degrees minus 105, that gives us 75 degrees. So angle 1 is going to be 75. And now that we know that, we can determine angle 2. Because the opposite angles that are across from each other are going to be the same. But also this is a straight line, and so 105 plus angle 2 will have to equal 180 as well. And so angle 2 is also going to be 75 degrees. Okay, now let's take a look at angle 4. Now these two lines are parallel, so they're intersecting the same line, so that means that angle 4 is going to be exactly the same as angle x. So angle 4 is also going to be 105. And then angle 5 needs to add to 105 to equal 180 because this line is also straight. So angle 5 is going to be 75 degrees. 75 here. Across from angle 5 is angle 6. Just like it was here, they're going to be equivalent. So angle 5 is 75, meaning angle 6 is also 75 degrees. And then adding to get us 180 between angle 6 and angle 7. Angle 7 will need to be 105. Because 105 plus 75 gives us 180 degrees, forming that straight line. Problem 31. Let's combine like terms. So what is a like term? Well, a like term means that the variables after the coefficient, which is the number in front, they have to be exactly the same. Exactly the same letters, exactly the same exponents attached to those letters. So let's look for that. And personally, I like to either circle the terms that are like or square the ones that are like. It just helps me visually so that I can start adding or subtracting their coefficients. So when I'm looking here, I see that this one right here is the same as this one. See, I've got a squared, b to the third, same thing here. Be sure to include the signs in front because they do matter. And then I also see that this one, including the sign, is also the same as this one here. Got a to the fifth, b squared, and c. So now what I do is I add and subtract their coefficients. Now I can only add and subtract the ones that are like. So here I can only add and subtract the squares. So I've got 5 minus 2 is going to give me 3. And all I do is just tack on the variables at the end, the term. And then I could do the same thing for these right here. So I've got negative 6 and negative 8 is going to give me minus 14a to the 5th b squared c. And then this one doesn't have anything for us to add it or subtract it to, so we're just going to leave it. Minus 4abc. Problem 32. True or false? Negative 2 is the solution set for this equation here. So the way that we can figure this out is we can substitute negative 2 for every time that we see x, and if both sides of the equation are the same, then it will be true. But if both sides of the equation are not the same, then it's going to be false. So let's just try here. So 3, and instead of x, I'm going to put negative 2 minus 6. That's going to be one side. And then I've got 2, instead of x, I'm going to put negative 2 minus 8. So order of operations says multiplication comes first. So 3 times negative 2 is going to be negative 6 minus 6. And that's going to give me negative 12 on this side. 2 times negative 2 is going to give me negative 4 minus 8. It's going to give me negative 12 on this side. And I see that they're both equal, so yes, true, that negative 2 is a solution for this set. Okay, number 33, convert 6 foot 3 inches to centimeters. So since what they gave me here is in feet and inches, I'm going to help myself out. I'm going to put the whole thing in inches. That's going to make it a lot simpler for us. So we've got the 6 feet, and we know that there are 12 inches in 1 foot. So I'm going to multiply that by the 12 inches to give me 72 inches. In addition to the 6 feet, I've also got 3 more inches. So I can add that to 3 inches, and I've got 75 total inches. Now I can convert to centimeters. So I can take 75 inches, and if you'll look on your formula chart, this conversion factor will be available to you during your exam. But I know that 1 inch is equal to 2.54 centimeters. Inches will cancel when I multiply here, and I can take 75 times 2.54, and that's going to give me 190.5 centimeters. Problem 34. A child is 61 centimeters tall. How many inches is this? Round to the nearest tenth. Now, this is exactly what we just did, except backwards. So this time we're starting with centimeters. We're going to use the same conversion factor we just used. 2.54 centimeters equals 1 inch. Centimeters will cancel. And I'm going to divide 61 by 2.54. And that's going to give me 24 point. We get a decimal here, but it asks us to round to the nearest tenth, so I'm going to put 24.0 inches. This video, problem 35, convert the following to scientific notation. Now, if you'll recall, the rules of scientific notation state that the first number needs to be between 1 and 10. So for part A, I need to ask myself, where would the decimal be if my number was going to be between 1 and 10? Well, I would put it right here, right? So that's the number I'm going to start with. So I'm going to start with 1.320. And then my goal is to figure out how many times I need to move the decimal to get it to where it actually is in the number they gave me. So let's count. Got 1, 2, 3, 4, 5, 6, 7, 8, 9. So times 10 to the positive 9. Why? Because my number is getting bigger here. All right? So let's try it with this one. Same question. I'm going to ask myself, where would the decimal need to be if my number was going to be between 1 and 10? Well, the decimal would need to be right here. Okay? So that would make my first number 2.53 times 10 to the, how many times do I need to move the decimal to get it to where it actually is? Well, let's count. 1, 2, 3, 4, 5, 6. Now, it's going to be 6, but this time it's going to be a negative 6. Why? Because my number is getting smaller. It's getting smaller. Where the decimal is, this number is going to be less than 1. And so my decimal is moving to the left, and my exponent is going to be negative 6. All right, so we're going to convert these numbers that are in scientific notation to standard notation. So let's start with A. I have 1.65, and it tells me how many times I'm going to move my decimal. And because the exponent is positive, I know that my decimal is going to be moving to the right because my number is going to be getting bigger. So it's going to move 6 times. So from here, I'm going to go 1, 2, 3, 4, 5, 6. What I like to do is put zeros in each of these little baskets that I've created. And so this leaves me with my number 165 and then 4 zeros. 3, 4. 1,650,000. Okay, for B, same thing. Our decimal is just going to go in the opposite direction because our exponent is negative. So I have 3.45. Move 4 times to the left. 1, 2, 3, 4. Decimal goes here, and zeros go in the little baskets I've created. They're just jumps. They're not really baskets. Okay, and so my answer is going to be 0. Got 3 zeros here, and then 3, 4, 5. Okay, problem 37. Multiply and express the result in scientific notation. So, as is right now, it's kind of difficult to multiply. But if we rearrange it in a format that is helpful, this might be a little easier. So what I'm going to do is I'm going to group the first numbers here together, and then I'm also going to group the exponents with the bases of 10 together. I'm going to rewrite it like that. So I'm going to take the 8.65, multiply it by the 2.17, and write it like that. And the same thing with the base 10 numbers. 10 to the 6 times 10 to the negative 4. Now this becomes a little easier. So I can multiply these numbers together. And when I do that, I get 18.77. And then I can also multiply these together as well. Now I know that when two bases are exactly the same, they have different exponents, I can add their exponents and keep the base the same. So what does that mean here? Base stays the same, so base 10, and add the exponents. So 6 plus negative 4 is going to give me 2. So if I rewrite this in like how we would normally see a scientific notation problem, I would rewrite it as 18.77 times 10 squared. Now, what's wrong here? Well, rules of scientific notation state that the first number must be between 1 and 10. And the first number here is 18, so I'm going to need to rearrange my numbers so that the first one is between 1 and 10. So I'm going to move my decimal so that the first number becomes 1.877, and what would that make this? Times 10 to the third. Exactly. Problem 38. Divide and express the result in scientific notation. Round to the thousandth. Okay, same thing here. As is, it looks a little confusing and daunting to calculate, but I'm going to regroup it to make it easier for myself. So I'm going to rewrite it as 8.65 over 2.17, and that's going to be my first parentheses, multiplied by 10 to the 6 over 10 to the negative 4. Okay, now these two numbers I can just divide by like normal. And when I do that, I get 3.986 times, now per our exponent rules, when I have two numbers that have the same base that are being divided by each other, but the exponents are different, or if they're the same, it doesn't matter, I can subtract the exponents and keep the base the same. So when I'm dividing here, subtract the exponents, base stays the same. So the base remains 10. Subtract the exponents, 6 minus negative 4 is going to be positive 10. So 3.986 times 10 to the 10th power. Question 39. Simplify the expressions. Okay, so we're going to use the exponent rules that we were just mentioning previously. When bases are multiplied together and the bases are the same, we can add the exponents. So here, I've got this x and this x. Base stays the same. Exponents are added together. So 3 plus 4 is going to be 7. And then for the y, base is the same. Exponents are added together, so the base is y. Now, it's not written here, but it's understood that this y has an exponent of a 1. So when I add 1 and 2, I get y to the third. And that is that one simplified. Down here, we were just talking about this exponent rule. When we're dividing two terms that have the same base, we will subtract the exponents. So here, I've got the a, base will stay the same, and I'll subtract the exponents. 5 minus 2 will give me a to the third. And then since there's no b on the bottom, I can just rewrite b to the 6th. We don't need to do anything to it. Problem number 40. Convert the mixed number to an improper fraction. Okay, so I'm going to, how we do this, it's very simple. For any mixed number that you would encounter, you're going to multiply the whole number by the denominator. So I always like to draw a little multiplication sign here. And then you're going to add the numerator. All of this will get you your new numerator. So 6 times 10 gives you 60. Plus 5 gives me 65. And then all that goes on the bottom is the denominator that you have in the mixed number. So 65 over 6. Again, multiply here, add here. That will give you the numerator. Problem 41. Perform the operations. Alright, so for the first one, we are adding a fraction and a mixed number. So I'm going to start by converting that mixed number to an improper fraction, just so I can add all fractions. So 1 and 2/3, we're going to use the technique that we just used on the previous slide. So times here plus here. 3 times 1 is 3. Plus 2 gives me 5. So 5 over 3. So now I can add those fractions in part A. So I've got 5/9 plus 5/3. Now, what needs to happen so that we can add these fractions? We need to create a common denominator. So for 5/3, I'm going to make this denominator a 9. Okay, so to do that, I need to multiply the bottom by 3. So that means that I would also need to multiply the top by 3 as well. So 3 times 3 equals 9, and 5 times 3 gives me 15. This is my new fraction here. Now I can add. So the denominator will stay the same. And I will add the numerators, and that will give me 20 over 9. Now, best practice is not to leave our answers in an improper fraction. We kind of would like them to be in a mixed number, unless the question asks otherwise. So I know that how many groups of 9 can I make out of 20? Well, I can make 2 for sure. And I would have 2 single units left. Okay. Now, part B. Here we are multiplying. So when we multiply fractions, we don't need to create a common denominator. It'll save us a lot of time. All we need to do is multiply top times top and bottom times bottom. And when I do that, I have 4 times 21 gives me 84. And 7 times 26 gives me 182. But I do need to simplify. So 84 and 182 are both divisible by 14. So I need to divide by 14 on the top and on the bottom. And that gives me 6 on the top and 13 on the bottom. Problem 42, rounding. Okay, for the first part, it says let's round to the nearest tenth. So let's look at the tenths place, so it's going to be right here. And I look to the right. And I see that this number is less than 5. So that means that this number in the tenths place is going to remain the same, and I don't need to write any other numbers. So up until this point, all the numbers on the left are going to be the same. So let's rewrite them as they appear. 5, 2, 3, 6 point. This will remain the same. And then I don't need to write the rest of these numbers here. Okay, let's try to the nearest thousandth. So thousandth place is going to be here. Look to the right, I see that it's larger than 5, which means that this number is going to go up, which means that this number will go up. So I'll rewrite it as 0.020. Okay, and then everything else on the other side is going to stay the same. So I'm going to copy it as it appears. So 6, 3, 2, 5, 7, 9, 1. Okay. Part C, to the nearest 10. So let's look at the tens place. I look to the right. This is bigger than 5. And so this number is going to go up. And everything else will become a 0. So this number is going to become a 4. So I got 1, 9, 7, 5, 2. This will become a 4. Everything else will become 0. But in this case, since I'm rounding here, I don't need to write 0.0000. I can just leave it like this. Okay, to the nearest 100. So I look at the hundreds place, and I look to the right. I see that this is smaller than 5. And so this can remain the same. So it's going to be 1975, 200. Okay, and then lastly, to the nearest 1,000, let's look at the thousands place. To the right, we see it's smaller than 5. So all these will become 0, and this will remain the same. So 1975, 000. Here. Okay. A heavy equipment rental store rents a backhoe for $300 per day with a delivery fee of $150. How much will it be for a 5-day rental? So let's create an expression for ourselves to solve our problem here. So there's a delivery fee, a flat delivery fee every time of $150. So I'm going to start with that. And then anytime it says per, we're going to be multiplying. So in addition to this delivery fee, it's going to be $300 per multiplying by the number of days. Okay? And they want to know how much it will cost to rent a backhoe for 5 days. So instead of X here, I'm going to put in the 5 days that we want to know. So 150 plus 300 times 5. Now we can solve. Per order of operations, 300 times 5 is going to give me 1500. Added to 150. And that will be 1650.